Okay, so I've got two problems on the screen. And what I'd like you to do is take a minute and see if you can figure out how to do at least one of them or both if you know how. But I'm going to give you a minute to try to figure these out. And then let's talk about them. So I think one of them's probably, in practical sense, one of them's probably too hard based on what we've been doing. And then one of them you should be able to do. So try to do at least one of them. And if you figure out the other one, awesome. Okay, so did anyone figure out how to do either one of them? No idea on any of them. One of them we can do for sure. What do you guys think?
The bottom one is just you split it up into U sub, right?
Yeah, so the bottom one you just split it up and you do like quick U substitutions. So you can split it up like this. And in both cases, U is the bottom. And so on the first one, du is just 1 dx, which means we get 3 log absolute value of x minus 5. And then on the second one, u again is the bottom. So du is 4 dx, which means we need a 1/4 outside. Whoops, too big there. But so we get 2 times 1/4 log absolute value of 4x plus 1 plus c. And then you can simplify that and you get 3 log absolute value of x minus 5 minus 1/2 log absolute value of 4x plus 1 plus c, and that's the answer. Does everybody follow that one? Any questions on that one? That one is pretty straightforward, I think. I think we've been able to do that one for a while. Maybe we didn't notice, but that's one we could have done even on the last exam, right? All right, any questions on that? Okay, any ideas on the first one? Did anybody try something on the first one, get it to work?
I started trying to factor out the denominator.
Okay, yeah, so that's a good idea. Did that get you anywhere?
Not really.
Not really? Okay. Any other ideas?
You could split it up into 2 different fractions.
You can, but if you do, you're going to get 10x over the bottom and 13 over the bottom. And then are we getting anywhere with that? Like that's something you should for sure try, Dominic, but is it working? Right. Yeah, it's not going to work, I don't think. Like both of what you guys said is right, and it doesn't really get you anywhere at this stage. Anyone else? What if the top had been 8x minus 19? Would we have been able to do this problem? Yeah, sure. So like if you could let u equal the bottom and du was 8x minus 19, or if this was like an easy multiple of 8x minus 19, we could get that. But we don't have that here. Does everybody see that? And so we don't know how to do this one yet. But if we notice that this is the same as this, then the answer is 3 log absolute value of x minus 5 minus 1/2 log absolute value of 4x plus 1. But you have to know that this fraction is actually equal to these subtracted. Does that make sense? No should probably be the answer. Probably that does not make sense at this point. So how did I know this was equal to that, do you think? Because I made it up that way. So I cheated and I knew that if I subtracted these, I would get this. So how can we verify that that's right? So like if you have 3 over x minus 5 minus 2 over 4x plus 1. So what I'm doing in red is in no way what you'd want to do to solve these problems, but I'm trying to prove to you that, okay, this is actually equal to this. So if you subtract those, we remember from algebra, you need to get like a common denominator. Does that make sense to everybody? So like you need to get a common denominator, which would be x minus 5 times 4x plus 1. And then the same thing on the second one, you need x minus 5 times 4x plus 1. And so the first one you multiply by 4x plus 1, so you get 12x plus 3. And the second one you multiply by x minus 5, so you get 2x minus 10. And now you subtract across the top. So 12x minus 2x is 10x. 3 minus negative 10 is positive 13. And then there's no need to multiply the bottom out. But if you do, it's 4x squared minus 19x minus 5, which means, okay, this is the same as this. And so because of that, you can rewrite this like the second problem, and it's actually exactly the same problem, and you get exactly the same answer. Does everybody see why this is the same as this from algebra? We've done that a long time ago, probably. Does that make sense to everybody? Now, would we want to do what I just did? So is there any reason why I would want to start with this and go to here on these problems? No, because none of us knew how to do this problem, and most of us could figure this one out, or once you were getting a quick reminder, you knew how to do this problem. So you don't want to go from these smaller fractions to this more complicated one. Although in algebra and when you're doing limits and things like that, there are reasons why this is better. So in algebra, you learn how to combine two smaller fractions into one with a common denominator, because there's stuff about this that's better. You could do horizontal asymptotes from here. You can do limits a lot easier probably from this form than this form. But for integrals, we would like to be able to go this way. We'd like to be able to start with this fraction and split it into these smaller ones. And that's something that you probably did not study in algebra. You may have a long time ago, but most algebra classes probably don't cover that. And the reason why is there's no practical reason why you would want these smaller component fractions until now. And so this is a lot easier to deal with. So what we're going to learn now is how do you take a fraction like this? And so how do I get this if I don't cheat and make up the problem where I know the answer already? Does that make sense to everybody? So the new thing, what we're going to cover is called partial fractions decomposition. That's a complicated way to say you're going to take a bigger fraction and break it into smaller ones that we can deal with. Does that make sense? So when we take this fraction and we split it into these, that's called the partial fractions decomposition. And so I want to go through that. And I want to go through that. You know what? Let's go through it with this one, and then we'll go through it with a different example. But the way you go about this is you take the fraction that you start with. And so let's do this in kind of this bright blue color so it's separate. But okay, so you take this fraction 10x plus 13 over 4x squared minus 19x minus 5. And the way you do it is actually what somebody had said is they factored the bottom. And now I don't think they were factoring the bottom with this in mind, but you do factor the bottom because of this method. So you're able to break it down into these component fractions. So if you factor the bottom, it factors into 4x plus 1 times x minus 5. And when we do the next example, I'll walk through one example of how we factor that. And if that's something that you are not comfortable doing, that's something we should for sure meet outside of class and go over, because you are going to have to be able to factor for these problems. And I understand that not everybody has a great background in factoring. And so if you want to meet up, today's probably not the best time for that because I teach right after this. But like tomorrow, we're not doing a live lecture. And so maybe tomorrow, if anyone wants to meet up and go over factoring, we can do that. But we do need to be able to factor something like this into 4x plus 1 times x minus 5. Now, once you do that, the idea is you're trying to find smaller fractions that would result in this being the common denominator. And so the way algebra works is that you could have 4x plus 1 as a denominator, and you can have x minus 5 as a denominator. And if you add those fractions, this is the common denominator. But if you have anything else as a denominator, if you add that in, this would not be the common denominator. So if I have even something simple, like if I have something over 2, a third fraction where the denominator is 2 would make this denominator 2 times all that. And so you wouldn't have this denominator. So the idea is these are the two fractions with simpler denominators, and we'll make it more formal what I mean, but what I actually mean is lower power denominators, lower degree denominators. So this is degree 2. These are the two with degree 1 that would result in this denominator. Does that make sense to everybody? Everybody clear? Okay, and then the goal is, so we knew, or I already knew the answer. I knew it was going to be 3 over this one and negative 2 over this one. I want to figure out what goes on top of there. And so if you're starting a problem from scratch, we don't know what goes on top of each of those. So what we do is we say, okay, well, it's some constant on top of this and some other constant on top of that. And we just represent those with capital letters. So we say, okay, it's some A and some B, and we need to figure out what they are. And so we're going to do a lot of weird algebra, but it turns out the algebra is easy once you get used to it. I think it's easier than the trig sub stuff. It's just weird algebra. It's algebra you've done, but maybe not quite in this way. And so the first thing you do is, the goal, first of all, is to solve this equation. Okay, solve this equation, not this first part, but this fraction equal to these two fractions. You're trying to solve this equation for A and for B. So we're trying to figure out what A is. We're trying to figure out what B is. The first thing you should do in order to solve that equation for A and B is clear the fractions. So you multiply both sides of the equation, and I'm going to erase this left-hand part just to not have a confusion with that. But you're going to multiply both sides of the equation by the common denominator. The common denominator is 4x plus 1 times x minus 5. And you want to think of that as being over 1. And we're multiplying both sides of the equation by that. And so on the left-hand side, when you do that, the 4x plus 1 on the top cancels with the 4x plus 1 on the bottom. And the x minus 5 on the top cancels with the x minus 5 in the bottom, leaving 10x plus 13 over 1 on the left. But since it's over 1, you can just put 10x plus 13. Does that algebra make sense to everybody? Is good? Okay, and now on the right, this fraction that I'm multiplying by, the common denominator, distributes to the two fractions independently. So if you're a little uncomfortable with algebra, maybe watch while I'm doing this and then copy it down later. But what you do is you distribute this over. And so on that first fraction, what's going to cancel? So on the one with A on it, what factor is going to cancel with the stuff up here? What do you guys think?
4x plus 1.
Yeah, the 4x plus 1 is going to cancel. And so that's going to leave A times x minus 5, but over 1. And I'm not going to actually cross it out because when we go to this one, it's still there. But on the first one, the 4x plus 1s cancel. On the second one, the x minus 5s cancel, so we get B times 4x plus 1. The denominator is then 1. Does everybody understand that algebra? Everybody good? Please ask if something is unclear. I know it's a little weird what we're doing. All right. So we're going to now distribute the A and distribute the B. So keep in mind those are constants. So we're going to distribute the A and get AX minus 5A. And we're going to distribute the B and get 4BX plus B. And now we're going to combine like terms in terms of X. So like we're going to get all of the, if there was an X squared term, we're going to get all the X squareds together. We're going to get all the X to the first powers together. We're going to get all the X to the thirds together. We're going to get all the ones that don't have X together. So on the right-hand side, we don't have any bigger powers than X to the first, but we're going to combine the X to the first terms. So we get A plus 4B times X. And so that's a little weird on the algebra, but it's like if this was 6x and this was 20x, you would add those and get 26x. Well, same deal here. If this is AX and this is 4BX, you add those, but you can't do like 20 plus 6 and get 26. Here, you do A plus 4B and you get A plus 4B. Does that make sense? And then the constant term, we're going to add, and so we're going to say plus the constant term, meaning the one without X, is negative 5A plus B. And you always want to force that to be a plus. So if something's negative, okay, but just group it. So you want that to be a plus, and if there's something else in front of this, you want this to be a plus as well. Okay, but you combine like terms in a little weird way, but you get all the X, like if there's X to the third, all the X to the thirds, all the X squareds, all the X's, and then all the constants. And you group them like that. Everything should be plus outside the parentheses. And now that's equal to 10x plus 13. And now the idea is this polynomial on the left must be the same as this polynomial on the right. So this has to be 10x plus 13. Does that make sense? Everybody clear? So then A plus 4B has to equal what?
10.
10. So because the left-hand side is 10x plus 13 and the right-hand side is 10x plus 13, then A plus 4B is 10. And then negative 5A plus B is 13. Does that make sense to everybody? Any questions so far? Okay, now we have what's called a system of equations. So we're going to try to solve this system for A and for B. And you learned in, Algebra 2, Algebra 3, a long time ago probably, how to do this. You can use substitution, you can use elimination, you can use matrices. There's lots of ways to do this. The first thing that would jump out at me is I would multiply the top equation by 5. You do not have to do it that way, but why would I look at that and immediately think, let's multiply that top one by 5? Why would that be a smart move? What do you guys think?
So the 5A's cancel out?
Yeah, so if I put this other equation underneath it, I can add them and the 5A's will cancel. So I'm going to multiply that top one by 5. I happen to notice that if I do that, I get those equations. And now if I add them, I get 21b equals 63. Does everybody follow that? You guys are good? And again, this is not the only way to solve this. So if you'd rather like solve for A and plug it into the other one, or solve for B and plug it into the other one, you can do that. But once you get here, B is then 3 because you divide by 21. And now you go back to one of the equations. So we know that A plus 4B is 10. So A plus 4 times 3 is 10. That makes A negative 2. Does that make sense? And so then this original equation, what we have now figured out is that 10x plus 13 over, that's a 13, not a B or whatever that was I wrote, but 13, that over 4x plus 1 times x minus 5, that is equal to A over 4x plus 1, so negative 2 over 4x plus 1, plus B over x minus 5, but B was 3. And so all of this work that I'm doing in red and blue is to prove that, okay, this is equal to this. It's how you start with this more complicated one and break it down. That's how you know to go from here to here. And on an integration problem, we would do all this work on the side, figure this out, and then split it into this and do the problem from there. Does that make sense? Okay, please ask questions because I know this is weird. It ends up getting where it's not terrible, but it's a lot of kind of tedious algebra at first, and then later the integrals themselves get harder. But right now, the hard part's the algebra. Everybody good? Yeah, Colin. So how about we go through an example completely all the way through? If you have a specific question, I'll answer that, but let's just do one cold and go through all the steps and see if it makes more sense. Is that fair enough? Okay, let me get one that I want to do. Yeah, let's do this. No, not this one. Let's do.
Does it matter which one you put A and B on?
It does not, but you would get a different value of A and a different value of B. So like, because I had A with 4x plus 1, I got -2. If you had B with 4x plus 1, your B would be -2. But the point is -2 goes with this one, and 3 goes with this one. Does that make sense?
Yeah, okay.
Okay. All right, cool. Other questions? Okay. Okay, so let's do this one from scratch. And so we're going to do the integral of 3x minus 7 over 2x squared minus 11x plus 12. And then dx. And so we'll talk a lot more next week about how to know when you're supposed to do this. But right now, basically, it's if the bottom factors and the degree of the top, and we'll talk more about this later, the degree of the top must be smaller than the degree of the bottom. What do I mean by that? What's the degree of the bottom here? Yeah.
X squared.
2, yeah. So because it's x squared, the degree is 2. The degree of the top is 1. Since 1 is smaller than 2, it's a possibility that partial fractions will work. Okay, so what we do, the first thing you do, once we determine that we're going to do this partial fraction stuff, is we're going to factor the denominator. So I'm going to do that on the side. There are lots of different ways that you learn in algebra to factor this. As in, people teach it lots of different ways. One way to do it is to take the first number times the last number. So A times C is 24. It's like A is 2, B is -11, C is 12. You need to come up with two numbers that multiply to 24 and add to -11. And those are -8 and -3. And then when there's 3 terms and there's a number in front, what you do with that is you split the middle term into -8x and -3x, but you keep the first and last terms the same. Then you do what's called grouping, which means you take out of the first two, we're going to take out a 2x. And out of the second two, we're going to take out a -3. And if you do all that right, these match. And you factor x minus 4 out, and you think, okay, to go from x minus 4 to this, you need 2x. And to go from x minus 4 to the second part, you need -3. And so that's the factoring. That's what I'm talking about. If you are not comfortable with this or with other factoring methods, that would be a good thing for us to do tomorrow at 12:30 if anyone wants to do that. If you do, just let me know after class and we'll set that up. But you need to be able to factor. If you learned a different way, fine, but you need to be able to go from here to here. So, okay, once you get it factored, you write the fraction with the factored denominator. So 3x minus 7 over x minus 4, 2x minus 3. Okay. And now we're going to do all this algebra on the side and not worry about the integral right now. So you break it into the smaller fractions. So the idea is all of the fractions with a smaller degree denominator that could result in this common denominator. So the denominators that could do that are x minus 4 and 2x minus 3. Does that make sense to everybody? In general, there could be more than 2 fractions. And so here there are only 2 because there's only 2 factors in the bottom. Then there's going to be a number on the top of each of those. So we don't know what they are. We got to find them. But we're going to call the number over x minus 4a and the number over 2x minus 3b. Does that make sense? Please ask if there's any questions at all. So I know this is weird. You guys good? Okay, so now we're going to multiply by the common denominator. The common denominator is x minus 4 times 2x minus 3. And you want to think of that as being over 1. That's going to multiply to both sides, which means it's going to go independently to all 3 fractions. So on the first fraction, both things in the denominator cancel, and you get 3x minus 7 over 1. Does that make sense? Okay, on the right-hand side, on the first fraction, the x minus 4 cancels, but the 2x minus 3 does not. And so you get a times 2x minus 3, but the denominator's 1, so you don't have to write it. And then on the last fraction, 2x minus 3 cancels, so you get b times x minus 4. Okay, questions on how I got that? Everybody good? Okay, one comment I want to make is that, so everybody kind of look at the screen for a minute. So when you're doing the first few problems of these, it looks like you are cross multiplying, like this times this and this times this. That is only true when there are exactly 2 fractions here. Does that make sense? So when you're doing the ones today and even the first several on the homework, it's going to seem like you just cross multiply. That is not true in general. When we get to the harder ones next week, there's more going on. So you really need to think of it as this common denominator, parts of it are canceling with parts of the bottom, and then parts of it are left over. Does that make sense? So try not to get in the habit of thinking, okay, you cross multiply or you're doing this one times this one, because on Monday that will start to be different. Probably for today, most of them, that's going to happen. And most of the ones you're doing between now and Monday, that's going to happen. But in general, that's not true. So you got to be real careful with that. Okay. Other questions so far? Any questions so far? Okay. So we're going to take a minute and now distribute the A and the B. So we get 2ax minus 3a plus bx minus 4b. And now we're going to combine like terms, but again, you're getting all of the powers of x together. So if there were any x squareds, we'd get those. We now are going to go to the x to the first. There are no x squared, so we go to x to the first. We get 2a plus b times x to the first. Let's make that a little bit neater. That's a b. And then we're going to get all the constants, just meaning the ones without x, and we're going to force it to be a plus. So we're going to write it as plus negative 3a minus 4b in parentheses. Everybody clear how to get that? That's good. Okay, now we're going to write, two equations, or in general, we might have more equations, but we're going to write a bunch of equations based on this. So the polynomial on the left is 3x minus 7. That means this has to be 3x minus 7. So that means 2a plus b has to equal 3. And then negative 3a minus 4b, because we put plus here, that has to be negative 7. Does everybody follow that? Good. Okay, now we ignore all this stuff up here for now. We're looking at these two equations and we're trying to figure out a way to solve for a and b. Lots of ways to do that. So however you learned in algebra is fine. I would look at that and immediately think, okay, I'm going to multiply the top one by 4 because then the b's will cancel. So if I multiply the top one by 4, I get 8a plus 4b equals 12. I add those and I get 5a equals 5, which means a is 1. Everybody good? And now we're going to plug a into one of the two equations that we had to begin with. So I'm going to pick the top one here, this 2a plus b equals 3. So that's 2 times 1 plus b equals 3. So you subtract the 2 over and you get b is 1. Okay, any questions to there? Okay, so what that means is this is really 1 and this is really 1. And so we can go back to the original problem and rewrite the problem as the integral of 1 over x minus 4 plus 1 over 2x minus 3. And now we can actually do the calculus part. All of the stuff to here is all this weird algebra, but kind of backward from what you normally do in an algebra class. Any questions at all, please ask if anything's unclear, because I know this is a weird thing to do. Is everybody comfortable doing that? Okay. So now ignore everything we've done except for this step that I've written. If you have to do that integral, what should you now do?
U sub.
Yeah, U sub, but we're going to split it first and then do U sub on both of them. And so we're going to get the integral of 1 over x minus 4 dx plus the integral of 1 over 2x minus 3 dx. The first one is log absolute value of x minus 4. The second one is 1/2 log absolute value of 2x minus 3 plus c, and then that's the answer we're going to go with. All right, questions? Everybody good? Okay. All right, so I'm going to put another one on the screen. And so we're going to do the integral of 7x plus 4 over 4x squared minus 25x plus 6 dx. And we're going to do something weird that we haven't done before in this class, but I want everybody to write that problem down. And then I'm going to put you into what's called breakout rooms. And you're going to have like 3 or 4 people in your breakout room. And we're going to give you probably 5 or 6 or maybe a little bit longer minutes to solve this problem. But I want you to help each other through it. All right, so you're going to have to turn on your mics. You don't have to turn on your camera if you don't want to, although I think that's better, but you don't have to. But I'm going to put you in breakout rooms. I want you to, I'll come around to the breakout rooms and see how we're doing. But write down the problem and then let's work on it together, okay? All right, so let me do these breakout rooms. We've got 21 people. So we'll do 6 breakout rooms. So you have 3 or 4 people in your room, and then I'll be around. If you're watching this video online, you should pause the video and do this problem and then check it here in a few minutes. The video will pick up when I present the solution. All right, you guys, so we are gonna show the solution. I think I already did, my bad. All right, so the answer is at the top of the screen. And then I'll scroll down and show what I did. See if what you got matches what I'm getting. But you should get -1/4 log absolute value of 4x minus 1 plus 2 log of the absolute value of x minus 6 plus c as the final answer. The order doesn't matter. You could have the 2 log of absolute value of x minus 6 first. But there should be a -1/4 with this one and a +2 with this one. The partial fractions part, let me see if it'll let me zoom out a little bit. All right. So the partial fractions part is at the bottom. There are several approaches to that, especially once you get down here, but the numerator of 4x minus 1, whether that's a or b, you should get -1 for that. And then the numerator of x minus 6, whether that's a or b, you should get 2 for that one. Let's take a few minutes, ask questions. Is everybody clear on what we're doing on that? Okay. Okay, any questions at all? This is making sense? Okay, so then what I want to show you for a minute is what you should be doing for homework for this. So before we advance on this stuff, so we can go into the harder stuff, but you have to be really, really comfortable with this process. Okay, and so I'm going to give you a couple homework problems that I would like you to do before Monday's lecture, and then we're going to get into the more complicated ones on Monday. But let me pull up this worksheet and show you the ones I'd like you to do. So it's in the shared drive in Unit 1, man, UNIT, right? So Unit 1, folder 7. In there are 4 files. And the first file is partial fractions. The second file is the answers, but not worked out solutions. The third file is a second worksheet on partial fractions. And the fourth one is the answers, but not worked out solutions to that. And on these, you don't get the worked out solutions just because most of it's just a lot of tedious algebra that can look a lot different from one problem to the next. But this is the worksheet I'd like you to work on. You should work problems 1, 2, and 3, but that's it. Okay, so based on what we've done today, you should for sure not do 4. It looks like the first 3, but it is in no way like the first 3. Maybe think about why it's not. And then 5, 6, 7, and 8 are more complicated versions of what we've been doing. There's something that's different about 5 as well. And then there's clearly different things about 6, 7, and 8. But you should do the first 3 on this worksheet and be comfortable with those before Monday's lecture, before we move on with this. Like I said, we have a lot more time today, but there's really no point in going on until we're really, really comfortable with this. So we're going to wait on that until Monday. And then I'm going to take these last 25 minutes. If you have questions, you're welcome to stay around and ask questions from the homework or whatever you'd like. You have a test next Thursday, so we need to be kind of getting on this stuff. It does include partial fractions, and it will include the stuff we're doing on Monday and Tuesday. Wednesday will be all review. So Wednesday, we won't have a live lecture. It'll be just a review session instead. There will also be a review session Wednesday night. And then Thursday next week, we won't have class at all because you'll have your 24-hour window to take your exam. All right. If anyone wants to meet up tomorrow, stick around after this and let me know that. Or if you want to stay and work on problems, do that. But if you are good, then have a good weekend, and thanks for coming. And I will see you guys either tomorrow or next week. Thanks, you guys.
So does this need turned in on CrowdMark?
It does not. We're not going to click that. Yep.